number 3 and 4. Question. Alright, so for this one, the first part of the test, or a portion of the test, it's going to ask you to solve for a missing angle measure or a missing side measure. So this goes back to what we did on that Wednesday, Halloween. You have to know what kind of triangle number 1 is. It's an equilateral triangle, which is also equiangular, and equiangular and equilateral triangles have angle measures that are each 60 degrees. So you have 60 degrees for every angle. Now that you know that this angle is 60 degrees, you can set 60 degrees and 5x plus 15 should be the exact same thing. And then find some way to solve it. Subtract 15 from both sides. $45 equals 5x. Then you would divide both sides by 5. X equals 9. That's all it wants is an x value. So number 2, you have to identify what kind of triangle that is. Ooh, it's going to be a long test. What kind of triangle is number 2? That is non-equilateral. It's an isosceles triangle. It's an isosceles triangle because these two angles are congruent, which means that these two sides are the same. So even if you misidentified it and you said it was equilateral, you got lucky. So now you should be able to say that 22 is equal to 8x minus 10. And then find some way to solve for x. I would add 10 to both sides. And then I would divide both sides by 8. Or on a multiple choice test, you can plug in numbers till you get the right answer. Okay, so first two questions are specifically about isosceles and equilateral triangles. Let's see what the future holds. Now we're talking about the first thing that we did, congruent figures. It says in the diagram, shape A, B, C, D is congruent to shape E, F, G, H. Find the value of x and find the value of y. So x is down here. That's AD. So which line on the other side corresponds to line AD? Line EH, the first letter and the last letter, correspond to each other. So these two things are described as congruent pieces, or CP-CTC, for those two shapes. 6x minus 12 is equal to 3x plus 9. And it's your job to solve for a value of x. I would, me personally, add 12 to both sides. And then I would personally subtract 3 x's from both sides to get all the x's on the same side. And then divide both sides by 3. X equals 7. Do I care how long the side is? No, I just care about x. Then it wants to know how big is y. Y is over here for angle G. Which other angle corresponds to angle G? Angle C, the third letter. So this angle and this angle are the same. 119 should be equal to 8y plus 39. To solve for y, you need to get rid of the 39. You subtract 39 from both sides. $80 is equal to 8y. Divide both sides by 8. So y equals 10. Not a lot of tough geometry concepts here, just a lot of algebra, right? So if you had a calculator, it might go a little smoother. If you don't have one, maybe you're better at it mentally. What kind of triangle is that? Isosceles triangle. So what do you know about 84 and 4x plus 20? They are equal to each other. Do you want to see how to solve that, or do you got it? You got it? You know, let me do it. Minus 20 from both sides. Divide both sides by 4. That's not right. Sorry, my calculator had an error. Because 16 times 4 is 64. Oh, here we go. Find the value of x. Any ideas here?
I don't know if this is right, but I did 3x minus 1 plus 4x minus 1 equals 180.
No, that's not going to work. You have to use 180 somewhere. I would probably do this first. That this 3x plus 1 angle and something add up to 180. So that would look like 3x minus 1 and something add up to 180. I don't know if that's going to work or not. Oh, never mind. Ooh, what's a tough one? Oh, wait, say what you did again?
3x minus 1 plus 4x minus 1 equals 180.
That does work. Do you know why it works?
Because they're
This angle right here is equal to this angle right here. Those two angles are equal because they're base angles of an isosceles triangle. So once you move this angle right here, these two angles should add up to 180. So you're right. 3x minus 1 and 4x minus 1 should add up to 180. Combine like terms. -1 plus -1 is -2. Then add 2 to both sides. Then divide both sides by 7. Two, 7. 27, right? Yes, sir. Sure. So that's pretty much the last chunk of like definitions for isosceles and equilateral triangles. Twist the knob. Twist the lock. 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 Twist the handle. Twist the handle. Boom. So now you can get it from the outside.
You may throw this away here.
That's fine. Can you wait a little bit, a minute? Hey. So in the next section, you can use definitions of equilateral and isosceles triangles, but this is purely a triangle interior sum theorem thing, like how many degrees are inside of a triangle. So how would you solve for x there? Or what do you know, like, do you know how big this angle is?
X is 20.
How big is that angle?
60.
That angle is 60. So by using the definition of an equiangular triangle, you can say 60 and 3x are equivalent. Then you can divide both sides by 3. And x equals 20. Okay, or you could say 3x plus 60 equals 180. In this triangle, you have to do that, right? There's 3 angles in the triangle. 1 angle is missing. You have to add all of them up so they equal 180 degrees. So 85 plus 65 plus 6x all add up to 180. Combine your like terms. 85 and 65 make 150. Then you'd want to subtract 150 from both sides.
Just 5.
And then divide both sides by 6. So x does equal 5. You plug that back in and say that angle is equal to 30, depending on what the question asks you. It may ask for the value of x. It may ask for the measure of the angle. So same thing for this triangle. You have 3 angles, kind of 3 angles in there, if you know the definition of what that little box means, and you're trying to solve for the missing angle. So this little box means 90 by definition. So you have 52 and 90 and something equal 180. Lots of algebra here. Combine all the like terms. 90 plus 52 is 142, plus 12 is 154. Subtract 154 from both sides. Is that right? I don't think I did that right.
I think it is.
Is it 142? 9. That's 142 plus 12 more is 154. So x equals 26. Which means when x is 26, 26 plus 12 is 38. And 38 plus 52 is 90, and 90 plus 90 is 180. So you could have jumped immediately there and said, I know this angle is 38, and then subtracted 12 from both sides. A lot of different ways to do that.
You could have just said, because that's 90 and you got to equal 90 to get 180. And you could have just took 50 to subtract 90.
That's what, yep. So on this one, x is on the outside. So if the angle on the inside is 30, how big does the angle on the outside have to be? 150. That's the definition. These two should add up to 180. And 150 and 30 would be the only way to make that happen. Oh, yes. Complete the congruence statement. It says Q, R, S, You must follow the same paths. You must go 2, 1, 3. It is congruent to which other figure? Y, X, Z. I guarantee you, on the test, it'll have 2 answers that look correct, but 1 answer will be listed in the incorrect order. It might say QRS is congruent to ZXY. That's not right. Please be careful. Well, everybody misses that question. Number 7, A is not the answer. Number 6, it goes A, B, C, D, 1, 90, 3, 2. You must follow the same order for the other shape. E, G, E, G, H, F. Follow the same order. And then everybody's favorite. Decide which method, side, angle, side, angle, side, angle, 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 side, or HL can be used to prove the 2 triangles are congruent. Number 1, what kind of triangle is that? A right triangle. What is the only way we ever proved right triangles were congruent? HL. Do I have L's?
Yes.
Do I have a set of H's?
Yes.
Yes.
Are you there?
That is the
Are you
HL
there?
theorem.
Are you there?
Hello? I do. Yes. Okay. Thank you. Bridget, your appointment was canceled today. Number 2. What do you have marked? You have angle is congruent to angle. You have a side congruent to a side. You have an angle congruent to an angle. So what shortcut is that? So this is the AAS. Is the S between the A's? So it's not ASA. It's either, I don't care how you write it. They mean the same thing. You have to identify multiple choice which one is the correct one. They'll say one or the other. They mean the same thing. Number 3, you have a pair of sides that are marked congruent. You have a pair of angles that are marked congruent. And you have a reflexive side that's congruent. What shortcut did you just generate? SAS. SAS. Matching. What? Good. All right, let's do it. How do y'all match? You do 1 to letters or letters to numbers?
I just draw.
Okay, but do you draw lines from the letters to the numbers or the numbers to the letters? Letters to the numbers. So you have ASA, you're looking for ASA.
Oh, I thought
Number 4 is an ASA question. You have SAS, you're looking for SAS. Number 2. You have HL, you're looking for HL. That's the only right triangle. You have SSS, you're looking for SSS. Number 1. What's that? Oh, 3 is the only one that's left? I love when a plan comes together. Which statement can you not conclude from the diagram? You could spend all day on this question. Is triangle QPS congruent to triangle SRP? Are those two triangles congruent?
Yes. The answer is C.
Yes, they are congruent. Do you know why they're congruent?
Because the QPR line.
It's the side angle side shortcut. You have this side is congruent to this side. You have this side is congruent to this side. And you have a pair of alternate interior angles that are congruent. That is the side angle side shortcut that proves those two triangles are congruent. And they are written in the correct order. So I can conclude that. It is not the right answer. Can you conclude that PQR and QRS are congruent? You have a side congruent to a side. You have a side congruent to a side. And you have an angle congruent to an angle. That is the SAS shortcut. Are they? PQR, that's blank 1 blank, and QRS blank 1 blank. Okay, they are congruent, and they are written in the correct order. QPT, and PTR. Are those the same? No. You have side. That's it. No anything else. So C. Cannot conclude that. Eliminated that one immediately because it is marked PQ and RS are the same. You can conclude that. They told you that. Oh, that's a tough one. Decide whether the triangles can be proven congruent by the given postulate or theorem. Number 13. Are those congruent by the HL theorem?
No.
No. Correct. Why can you not conclude that? No right angle. So you write no. Because there's no right angle. You cannot conclude that. Can you conclude that TWX and YWX are congruent by the side-side-side shortcut? No. Because that's the angle side angle shortcut, not the side-side-side shortcut. State the congruence that is needed to prove the two triangles are congruent using the given postulate. So you want to prove those two triangles are congruent by the HL shortcut. What else do you need? You have an L. You need an H. So you need to mark that these two things are congruent. That's what you're adding. Now they are congruent by the HL shortcut. Number 8, you want to prove those two triangles are congruent by the angle side shortcut. What additional piece must you mark? You have to pick one of the, so you can pick this one, which would be perfect. That is angle side. There is another option. The only wrong answer is you cannot mark these two lines are congruent. Cannot do that, otherwise it would be the angle side angle shortcut, not the angle side shortcut. Is it possible to prove that triangles are congruent? If so, state the postulate or theorem you used. So I want to prove that ABD is congruent to CDB. Can I prove those two triangles are congruent?
Yes.
Yes. What postulate or shortcut did you use? What is that? Side angle side, or SAS. Number 10, are those two triangles congruent?
Yes.
Yes. What shortcut did you use? HL. You have the HL shortcut. Oh, yes.
I hate this thing.
It will look exactly like this on your test. The only difference is on your test, these blanks will be filled out for you. Hence, I will do it. LM is congruent to LM. So that's how your test will look. You will only be expected to fill out reason 9 and reason 11, and they will be multiple choice. So I'm asking you, why is LM congruent to LM?
Good.
The reflexive property. So right now you said that line is congruent to that line. You have angle K, which is congruent to angle N. And you have angle KML, which is congruent to angle LM or NML. So what shortcut did you use to prove those two triangles are congruent? Angle, angle, side, or side, angle, angle, they mean the same thing. Okay, let me fill out everything that you need. It says, and it's marked that MN and PQ are the same. It says, and it's marked that MQ and NP are the same. It will also say on your test that QN is congruent to NQ. It will also say on your test that triangle MNQ is congruent to triangle PQN. It is your job to fill out reason 10 and reason 12. Why is QN congruent to NQ? The reflexive property. Why are those two triangles congruent? The side, side, side. Shortcut. At this point, your entire review should be completed. Correct or incorrect?